Every time I see a new blockchain project, I always wonder, is it worth my time or should I just stick to Ethereum? Algorand is an up-and-coming blockchain that has $1 billion available for various grant programs. This is really impressive, and I've never seen a blockchain spending so much money on developers. So what is Algorand, how it works, and how you can get paid to learn and build on Algorand? That's what we'll see in this video. If you are new here, I'm Julian, and on Eat the Blocks, I teach blockchain development.
We are going to start our exploration of Algorand with its consensus algorithm. Algorand has a new type of proof-of-stake consensus algorithm called pure proof-of-stake. Thanks to this new consensus algorithm, Algorand is able to solve the blockchain trilemma by being both decentralized, scalable, and secure. For each new block, the network randomly chooses one node to act as the block proposer and a set of nodes to act as a committee of validators. The block proposer proposes a block with transactions and an updated blockchain state, and the committee of validators verify that this block is correct and add it to the blockchain. Because the block proposer and the validator committee are chosen randomly, it's very difficult for a group of nodes to collude and hack Algorand. This approach also maintains decentralization since validator nodes are chosen randomly by the algorithm. Because the validator committee is a subset of all potential validators, it's easier to coordinate the validator committee, which leads to a faster block time and more scalability. Algorand is able to process 1,000 transactions per second. Soon this will be increased to 3,000 transactions per second, and long-term the objective is to reach 45,000 transactions per second by using a shard architecture similar to Ethereum 2.0 with so-called co-chains. Algorand has a block time of 4.5 seconds. Transaction fees are very cheap on Algorand. For example, recently an NFT project was able to mint millions of NFTs for a few $1,000s, whereas on Ethereum, to mint each NFT, it would have costed between $50 to $100. Another important feature of the Algorand blockchain is instant transaction finality. This means that there is no fork possible, no need to wait for confirmations, and any transaction added to the Algorand blockchain is final. So that's it for the consensus algorithm of Algorand. Next, we will see the main features of Algorand Layer 1, including smart contracts. Algorand Layer 1 is the main chain of Algorand. To interact with Algorand Layer 1, you need to send a transaction. Contrary to Ethereum, there are several transaction types. In each transaction, the type of transaction is specified in a field, and the other fields contained in each transaction depends on the type of transaction. On Algorand, when you want to have a token, you don't need to deploy your own smart contract. Instead, you can rely on Algorand standard assets, or just ASA, which is a mechanism to create and manage tokens directly embedded in the Algorand blockchain itself. It covers fungible tokens called ERC20 on Ethereum, as well as non-fungible tokens called ERC721 on Ethereum, and security tokens, which are tokens that represent a real-world asset like a stock or real estate. To create and manage Algorand standard assets, you use transactions. It's possible to configure an asset manager that has some special powers like revoking and freezing some accounts. Before you transfer an asset on Algorand, the recipient has to first opt in to receive the asset. This is different from Ethereum, where everybody can send any asset to your address, which can result in a lot of spam transactions. On Algorand, you can also use smart contracts. Smart contracts runs on the Algorand virtual machine, or just AVM. This is not a fork of the EVM of Ethereum, this is a custom implementation. Smart contract can manipulate the local state of a user account or the global state of the Algorand blockchain. The Algorand used for smart contract is called TIL, which maps almost directly to the elementary instruction used in the AVM, also called opcodes. TIL is quite low level, and most people don't use TIL directly to write their smart contracts. Instead, most people write the Algorand smart contracts using a higher level language called PyTIL. PyTIL is a Python library. A lot of people are familiar with the Python syntax, so it should make it easier to onboard new developers. Another option for writing smart contract is TLang, a C-like language created by the Algorand community. The last option to create smart contracts is to use the Rich tool. This is a tool to abstract the details of the Algorand blockchain, and it allows you to only focus on your business logic. Rich smart contracts are written in a custom language that looks like JavaScript. Rich is able to create mathematically verified smart contracts based on the business logic. Besides the smart contract part, Rich can also build a complete dApp with many different front-end possibilities like React. As a side note, Rich is also able to compile smart contracts for the Ethereum blockchain. Smart signatures are another kind of smart contracts. They are similar to smart contracts but are used to delegate signature authority. It's similar to when you give some institution a limited authority to withdraw a monthly bill from your account. The logic of the signature determines when and how this withdrawal can take place. It can be written the same way as smart contracts. Another cool feature of Algorand is atomic transfer. It's possible to send several transactions at the same time. You can send up to 16 transactions in an atomic transfer. They either all succeed or all fail. It can be used to combine various layer 1 features of Algorand. For example, you could have a smart contract call combined with a payment transaction. If the smart contract call fails, it will also prevent the payment transaction. And you don't need any smart contract for atomic transfer. It's a built-in feature of Algorand. So that's it for the main features of Algorand Layer 1. Next, we're going to see some important tools that you need to know as an Algorand developer.
In addition to running an Algorand node, it's also possible to run an indexer. An indexer provides an easy-to-use API to quickly get some blockchain data from the Algorand network. The indexer works by connecting to an Algorand node, storing data in a database, and building an index for fast retrieval. Technically, you can get all the blockchain data directly from an Algorand node, but for some kind of data, it requires more effort. With an indexer, it can really simplify building an application on Algorand. Another very important tool for building Algorand dApps is the Algorand SDK. The Algorand SDK is a library to easily interact with an Algorand node. Think of it like Web3 for Algorand. Algorand maintains 4 SDKs. In Golang, in Java, in Python, and in JavaScript. There are also other SDKs maintained by the community in Rust, .NET, Swift, and more. Another useful tool is the API of RenLab. Think of it as Infura for Algorand. It allows you to easily interact with the Algorand network without running an Algorand node yourself. And its API is completely free without any API key required. An alternative to RenLab is PureStack API, which offers some free endpoint and some paid extra options. Then you have Algo Explorer, the blockchain explorer for Algorand, which was built by RenLab that I just mentioned before. Algorand also has a public testnet with a faucet to get some testnet algo. When it comes to wallets, the equivalent of MetaMask for Algorand is called Algo Signer, and it's available as a Chrome extension. And there is also the official wallet of Algorand, simply called Algorand Wallet. There is a mobile wallet available for iOS and Android. Even though this is a mobile app, it can also be used in web applications by using the Wallet Connect API. Enough for development tools on Algorand. Next, we're going to talk of how you can get money as an Algorand developer. There is more than $1 billion available to support the Algorand ecosystem. Most of these funds are for developers and builders, but not only. The sheer amount of money, $1 billion, is really impressive. I've never seen other blockchains offering so much money to support the ecosystem. There are 3 grants coming from the Algorand Foundation. First, there is the $2 million Trailblazer Bounty Program. This money will be given to developers over 2 years in exchange for completing bounties. There are community, marketing, and technical bounties like doing some code contribution or creating documentation. There is also the $250 million Algo Grant Program, which is to support a wide scope of projects on Algorand like infrastructure, tools, research, education, and application development. And then there is the $300 million Algo Viridis Fund to support DeFi projects on Algorand. And in addition to these grants from the Algorand Foundation, there is also a lot of funding coming from other entities. So no matter what you want to do on Algorand, from learning to helping the community to building your own Algorand dApp, there is money available to support you. So now you have a high-level overview of Algorand, and it's time to start building on it. And for this, you can get started with the official documentation of Algorand at developer.algorand.org. They have some code examples using ripple.it, an easy-to-use in-browser IDE, as well as getting started guides for quickly deploying your first Algorand dApp. Another interesting resource is this list of development tools and community projects. You will learn about wallet, SDK, API services, and utilities useful for building on Algorand. And finally, there is an active developer community on Discord. I put all these links in the description down below. Thanks for watching this video and have a good day. Bye.